Good morning, Dr. Lai. My name is LIM HAO LEONG, and my metric number is 24006-105-1. Today, I'm going to talk about electrocardiogram, which is ECG. The objective of my assignment is to have an overview about the circuit in a regular electrocardiogram. Besides, it is to understand the system and the mechanism of electrical components in a regular electrocardiogram. Lastly, the objective of this assignment is to leverage the knowledge of circuit theory in the design of medical devices, ensuring they incorporate the appropriate mechanisms and functions relevant to the field of biomedical engineering. Now, let me introduce what is ECG. ECG is a simple, non-invasive test that measures the electrical activity of our hearts. It functions to record the electrical signals in the heart and analyze it in the form of P wave, QRS compressed, and T wave. The results can aid the doctor to diagnose the heart attacks and irregular heartbeats, which is arrhythmias. Now I will introduce what is first-order circuit. First-order circuit is defined as a type of circuit that contains a resistor and only one type of storage element, either an inductor or a capacitor. There are two types of first-order circuit, which are RC or RL circuits. And this is the ECG circuit diagram of my assignment. At the right side, we have ECG circuit analysis. Totally, there are 6 electrical components in the ECG circuit diagram. First one, resistor, capacitors, operational amplifiers, instrumentation amplifier, signal sources, ECGP, ECGN, and noise source. Lastly is the voltage reference. The type of circuit in this ECG circuit is the first-order circuit, which is RC circuit. In the circuit design of ECG, there are 3 main implementations. First one, instrumentation amplifier, which is known as INA333, filtering part, and the right leg drive circuit. So this is the circuit design of the INA333. So this amplifier is designed to amplify the differential signals while rejecting the common mode noise such as interference or noise that affects both input lines equally. There are 6 parts in this INA333. First one, operational amplifiers. There are 3 operational amplifiers known as A1, A2, and A3. A1 and A2 functions to amplify the difference between the 2 input voltage, and A3 combines the output of A1 and A2 to produce a final amplified output and the voltage output. Secondly, resistors. The 50k ohm resistors function to ensure high input impedance and help the input stage to reject the noise. The 150k ohm resistors function to control the gain of the amplifier to ensure a stable and accurate amplification. Lastly, the gain resistor functions to determine the overall gain of the instrumentation amplifier. Next, we proceed to IFI filter inputs. These inputs function to ensure that the signals entering the amplifier are clean and free from the unwanted noise. Besides, we have power supply pins, voltage positive and voltage negative. These pins functions to provide the positive and negative power supplies needed for the amplifier to operate. In addition, we also have reference pin that allow the flexibility in adapting the output to the requirements of the application. Lastly, we have voltage output that combines the contributions of A1 and A2 to give a clean amplified version of difference between the positive voltage and the ground voltage. Next, we are moving on to the filtering part. This part is divided into 2 parts, which is high-pass filter and low-pass filter. And these 2 filters are designed with the RC circuit. In the high-pass filter, it functions to remove the low-frequency components such as the baseline wonder and irregular baseline, which may result from the patient movement, breathing, or electrode skin interface changes. Then, for the low-pass filter, it functions to eliminate the high-frequency noise such as EMI from the surrounding devices or the power lines. And this is the circuit design of the filtering part. Lastly, let's proceed to the last implementation, which is the right leg drive circuit. This circuit functions to reduce the interference from the amplifier, and it also functions to amplify an ECG signal and create a DC common mode bias electrically off the inputs of the differential amplifier. Let's look at its operation. The right leg drive inverts and amplifies the average common mode signal back into the patient's right leg. This can cancel 60 Hz noise from the AC power and creates a cleaner ECG output signal. In the conclusion, we will discuss about first order vs second order in ECG. With the advancements in the medical technology, the performance of the ECG system can be significantly enhanced by incorporating it with the second-order circuits. These circuits offer improved signal filtering and precision compared to the first-order circuits, and they bring better noise reduction and more accurate extraction of the critical biosignals. The use of the second-order filters allow for sharper frequency cutoff, effectively separating the desired ECG signal from noise and interference, ultimately improving the reliability and diagnostic capability of ECG systems. Thus, although the second-order circuit is more complicated, it does provide a better mechanisms than the first-order circuit. That's all from me. Thank you.